Hi guys, my name is Mathis Kretz. I work for Swisscom. I work for the IT Cloud tribe in Swisscom. We make the Swisscom cloud products and we operate them. And I lead the cloud empowerment team in this tribe, which is a team of a small team of cloud experts who help our customers, internal and external customers, in getting started in cloud-based engineering and cloud-native engineering. That's my day job. And today I'd like to show you what we have done with Elasticsearch in order to offer it as part of our Cloud Foundry platform, or more specifically in the marketplace of our Cloud Foundry-based platform called the Application Cloud. So this talk, in a sense, will be less about details of features of Elasticsearch or Logstash or Kibana, but more about the way we are offering this on our platform and the way we have integrated it with Cloud Foundry. So let me quickly outline what I plan to cover in this half hour that I will be speaking. So first, I'm going to give you a short overview of the sample application which I use to demonstrate how the setup works. Then I need to explain to you what a service is in the context of Cloud Foundry. A service, so Elasticsearch itself will be is run as a service in our platform. I need to show you what pushing apps means. So what pushing an app means, because Logstash and Kibana in our world are deployed as apps in our platform. I'm going to give you some more details about the Logstash build pack, which is basically the component which deploys Logstash with a certain config, and the same for Kibana. And then I'm going to show you which mechanism of Cloud Foundry we use to connect an application to, in a sense, an ELK stack that we have built on top of these components, or using these components in order to drain logs to the ELK stack. So here's my sample application, and actually the relevant bit for this gathering here is more the lower part. So the upper part is just an example app that I usually use to demonstrate certain things about Cloud Foundry. And down here we can see what we'll be seeing is that we are running Elasticsearch as a service in Cloud Foundry, and that we have two apps, one Logstash app pushed to Cloud Foundry and one Kibana app pushed to Cloud Foundry. These are connected to the Elasticsearch service. And then we have this thing here, the Logstash, so the syslog terrain, which is used to bind individual applications to our Logstash. The application itself has a little UI where you can enter some notifications. It then has an API which stores these notifications in a DB. It has a little message queue which where the notifications are queued, and a little mailer process which consumes the queue and sends mails via Mailgun. But this is just to have an application that does something fairly real. Right. So maybe let me give you a short tour of how Cloud Foundry works as a PaaS platform, so that you have a bit more context here. Here you can see our web front end, that our instance of Cloud Foundry features. And here in the left-hand navigation bar you can see at the top level so-called orgs. So orgs are typically projects, development projects that you are hosting on this platform. And an org is subdivided into several spaces, and spaces are typically stages of development. So you have a space, you would have typically a space for dev, a space for prod, maybe a space for test, or whatever other stages you have. And in this scenario, I want to show you that we can use basically one instance of Elasticsearch and aggregate logs from various stages even of our development process. This is actually a special setting, as usually services in Cloud Foundry are scoped to a space, but you will see why in this case we can use one instance of Elasticsearch to basically aggregate logs over several spaces. So if I now go into one of these spaces, I see I have an instance of my sample application here deployed. This is my dev space, so this would be where my developers are working every day to add new features. I have my API, my mailer, and my UI. These are apps. So these are things which have been pushed as apps. And on the other side, I have services. I have my DB, my message queue, and also my mail, my external service to which links to Mailgun. If I go to my prod space, I have the same thing. So this would be my productive instance of my application, again with my 3 apps and my 3 services deployed. And what I've added now for this presentation is I have added a space called logging, which contains one central installation of, in a sense, the Elk stack with Kibana, Logstash, and an Elasticsearch instance to which these 2 apps here are connected. And we will be using this instance to aggregate logs from all of the spaces that I've just shown you. By the way, here, if I can already access my Kibana. And as you see, at the moment, my Kibana is empty, so there is I don't see any traffic. I don't see anything in my indices in the last 15 minutes. So this is the Kibana that is running in the space I just showed you. So the first concept I'd like to, or I have to explain to you, is what a service is in the jargon of Cloud Foundry. So a service is any resource that is offered by the platform and can be consumed by apps. So this is typically a database or a message queue. As we've seen, MongoDB, we also have MariaDB, we have Redis. As a message queue, we have RabbitMQ, but we also have things like S3 compatible blob store, and one particular service that we also have is the Elasticsearch. So the service broker for the Elasticsearch service, basically for every instance that is created, creates a dedicated Elasticsearch cluster for this new instance. And I can, as a user of the platform, I can query the marketplace to check what I have at my disposal. I can do this either on my web front end. This is usually not very interesting for developers, but more useful is the command line. So I can use the command line client of Cloud Foundry to query the marketplace here. And I see that I have an Elasticsearch service, and I can choose from a number of plans. So ranging from XX small to X large. This is just the sizing of the cluster that will be provisioned by the service broker if a user chooses to instantiate this service. And what I've done ahead of time is, so let me quickly go to the logging space and show you the services again. What I've done ahead of time is I've instantiated an Elasticsearch instance. I've taken an X small here because that's what I need for my demo. And I did this using CF create service. Sorry. So I issued the command CF create service, Elasticsearch to choose the product, then the plan and the name, which I've chosen to be notification ES. And this name I can then reference from various applications to access this service. All right. Now the second important aspect of our platform is deploying apps or pushing apps. So what does that mean? That means I'm basically deploying source code to the platform, and this is usually achieved by basically creating a manifest YAML in the root of your code base, which tells the platform how this code base is supposed to be running or is supposed to be run in the platform. So for example, when we push Logstash to the platform, we use the Logstash build pack. So the first line of this manifest basically references this build pack to tell the platform what build pack to use. And then I need to give my Logstash instance a name. In this case, I choose notification Logstash. I need to assign it a memory size, and I need to tell the platform to bind my Logstash to my service instance, my Elasticsearch instance. This I do by specifying this as a service here. And I need to give my Logstash a route. And the route is basically a URL under which this Logstash will be reachable from outside of the platform. And then once I have this manifest at the root of my folder, or my source code, basically deploying is as easy as issuing cf push as a command. And from this point on, the relevant build pack, in this case the Logstash build pack, takes over. It uploads app code, which in this case just means it picks up the configuration that I have in my local directory. It creates a container. It installs a technology-specific runtime, which in this case is it installs Logstash. It binds services. So in this case, it binds the Elasticsearch to the container. It runs technology-specific build. So in the case of Logstash, this would be basically running a templating engine over the various config files. And in the end, it basically deploys my config to the right place in my Logstash installation, maps as a last step the route to the app, and starts the container. So let's have a look at the Logstash build pack in a bit more detail. What do I do to push Logstash as an app? Basically, I create a file structure like so. So in particular, I have a Logstash file, which is the top level configuration. And I have my manifest file, which tells Cloud Foundry how to deploy. And then I can add a confd folder where I have a number of Logstash configuration files, for example, for configuring filters, inputs, and outputs. I have a curator-d directory where I can put my curator config for managing my indices. And I can also add things like grok patterns and whatever I need to reference from my config. So let's have a look at my example here. So this is my example config. Here's my manifest YAML that I need for Cloud Foundry. This I've already shown you. And for example, here I have a filter config that applies a certain grok pattern to my input, and it also applies the JSON filter to my input and adds some tags depending on what kind of transformations were done. And I have an output config which, depending on a certain tag, puts my logline in an index called parsed, or puts it in an index called unparsed. So here, this is just an example configuration. Here you could really add your very specific Logstash config that you need for your specific use case. I've also added a curator config, which basically just deletes any index which is older than 5 days. So I'm matching for the index pattern parsed, older than 5 days, and for the index pattern unparsed, also older than 5 days. And I'm saying the action is delete indices. And here I have my curator config, which tells curator how to find Elasticsearch, and also how to authenticate against it, etc. This is my Logstash config file. Here I'm also adding some credentials so that I have to provide username and password when accessing my Logstash. And I'm adding a config template called cf input HTTP, which basically is an input definition for receiving syslog traffic via HTTP. And this is the switch which also enables curator to run according to a certain schedule. If we go over to Kibana, this is a rather simpler config I've chosen here. Again, here you see the Cloud Foundry configuration. You see here that I'm choosing the Kibana build pack for deploying Kibana. I'm calling it notification Kibana, and I'm connecting it to the Elasticsearch service instance and giving it a route called notification Kibana scap.io. And I'm just installing the Xpack plugin here for this example. Right. So now I need to show you how, so we've got our little elk stack set up, but it's not yet connected to anything in Cloud Foundry, to my apps. And I need to show you how to do that, or how that is done in Cloud Foundry. This works via the concept of user-provided services. So a user-provided service allows you to bind your apps to things which are external to the platform or which are not in the service marketplace, but you can bind them in the same way as if they were in the marketplace. And we're going to define the Logstash app that we have pushed into our platform as a user-provided service. And we need to use the syslog terrain option when creating this user-provided service. And that means that, so this is the -L option. This means that this user-provided service will forward logs to a syslog-compatible consumer, which in this case is our Logstash our Logstash app. So this is the command I will issue. And let me just, we need to target first my prod space. Sorry, I have created. All right, so I have now created this Logstash terrain service here, and I can now bind this service to my various components. So I can bind it to my UI, I can bind it to my API, and I can bind it to my mailer process. And as you see, the platform is telling me I need to restage these applications now because they have been bound to a new service. That's a Cloud Foundry specific thing. So whenever you've dynamically bound a new service, you need to make sure that the application picks up the environment variable or the actual service binding associated with it. So you need to restage the apps. This is actually not something you would realistically do dynamically, but it's more to show here how the mechanism works. Normally, you would obviously already declare a binding in your manifest so that when you push an app, all of the service bindings are already performed on deployment. So let me quickly restage all my 3 microservices here. And so my UI is missing. I need to do that as well. And now, as these apps are restarting in the platform, I should be seeing logs that are delivered, as you can see, in the last 15 minutes. So since 7 o'clock, there have been now logs delivered from various apps. So here you can see my UI has delivered logs. Let's check if I can also find. So we see the log traffic arriving from my various apps, and I could now also go to my dev space, create the same user-provided service, again pointing at my central Logstash instance, and I could start binding my apps here in this dev space. And like this, I would have basically logs from my whole project arriving in my central Elk stack. So I think that's, in terms of time, the end of my lightning talk here. Thanks, guys.